Good day, everyone. I'm Teacher Rowena P. Aspiras from Anonas National High School. Today, I will discuss Quarter 3, Week 2 with Learning Competency Solves Problems Involving Permutation of Objects. Let's have the points to remember. In solving problems involving permutation of objects, we're going to consider the following. Rule number 1. The number of permutation of n distinct objects taken all together is n factorial. Using the formula, the permutation of n object taken n at a time is equal to n factorial, where n is the number of objects and n is the number of objects taken at a time, or we can say taken all at a time. Rule number 2. The arrangement of n objects in a specific order using r objects at a time. Using the formula, permutation of n object taken r at a time is equal to n factorial divided by the quantity of n minus r factorial, where n is the number of objects and r is the number of objects taken at a time. And don't forget, n must always be greater or equal to r. Rule number 3. The arrangement of n objects in a circular pattern is given by the formula P equal to the quantity of n minus 1 factorial. Rule number 4. The number of distinguishable permutations of n objects when P are alike, Q are alike, R are alike, and so on is given by the formula P equal to n factorial divided by P factorial, Q factorial, R factorial, and so on. This time, let's try to solve similar problems on Activity 1. Find ways or arrange. Direction. Solve the following problems. Show complete solution. Suppose that in a certain association, there are 12 elected members of the board of directors. In how many ways can a president, a vice president, a secretary, and a treasurer be selected from the board? Analyzing the problem, there are 12 elected members of the board of directors, and this will represent your n, the number of objects. And you can only select a president, a vice president, a secretary, and a treasurer. That will represent your R, which is 4. So from that alone, we can select the correct formula, that is the permutation of n taken r at a time, equal to n factorial divided by the quantity of n minus r factorial. Let's have the step-by-step solution. Write the correct formula, n factorial divided by the quantity of n minus r factorial. Do the substitution. Replace n by 12 and r by 4. Then simplify. 12 minus 4 is 8 factorial. Then do the cancellation. Then what is left is 12 times 11 times 10 times 9. And that is equal to 11,880. So the permutation of 12 objects taken 4 at a time is equal to 11,880. Let's have another problem. In how many ways can 5 people arrange themselves in a row for picture taking? Analyzing the problem, There are 5 people that will represent your N. And at the same time, will represent your R. Mean to say, your N is just the same with your R. So therefore, we're going to use the formula for the permutation of N taken N at a time. Or mean to say, taken all at a time. And that is equal to N factorial. So let us solve the problem using the correct formula, the permutation of N taken all at a time. And that is equal to N factorial. Do the substitution, replace N by 5. So we have 5 factorial. And 5 factorial means 5 times 4 times 3 times 2 times 1. And that is equal to 120. Means there are 120 ways the 5 people can arrange themselves in a row for picture taking. Let's have another problem. How many distinct permutations can be made from the letters of the word probability? This problem is an example of distinguishable permutation, where some objects are alike. Or to be more specific, there are letters that are alike. And the correct formula to use is P equal to N factorial divided by P factorial times Q factorial times R factorial. From the formula, N will represent the number of objects, the number of letters from the word probability, and that is equal to 11. Letters P, Q, and R will represent the letters that are alike. And in the word probability, there are 2 letter B. And also 2 letter I. Applying the correct formula, P is equal to N factorial divided by P factorial times Q factorial, where N is equal to 11, B is equal to 2, and I is equal to 2. B will represent P, and I will represent Q. So do the substitution. Replace N by 11, P by 2, and Q by 2. Simplify. 11 factorial divided by 2 factorial. Do the cancellation. Cancel 4 and 4. Then we have now 9,979,200 distinct permutation that can be made from the letters of the word probability. Another problem. In how many ways can 10 different colored horses be positioned in a carousel? The key word there is the word carousel. A carousel is a fixed round or a merry-go-round object. So mean to say, we are looking for the different possible arrangement of objects in a circle. So this problem is an example of circular permutation. And the correct formula to use for this problem is P equal to the quantity of N minus 1 factorial. Applying the formula for circular permutation, P equal to the quantity of N minus 1 factorial. Replace N by 10, the number of objects, subtract it by 1, that is equal to 9 factorial. Applying factorial means, so we have P equal to 362,880 ways. The 10 different colored horses can be positioned in a carousel. So thank you and stay tuned for the next virtual instruction.